My first introduction for the day is that of Rinse Kloek. Rinse has been regular at NLNOG meetings. He's told us everything about his adventures in the access world. Everything from fiber to the farm. That was one of the first, I think. And today he's here to tell us a little bit about an infamous protocol, DHCP. And to be more specific, migration of the, well, what can I say, ISC DHCP, let's not put an adjective in front, to KEA. So, Rinse, the floor is yours.
Thank you for the introduction, Niels. Today I'm going to talk about the nicest protocol there is, DHCP. Somebody say DNS is the nicest one, but I think it all starts with DHCP. Without DHCP, you have no IP. Especially, I'm going to talk about the migration from ISC to KEA DCP. What are the topics in the presentation? First of all, what is the reason Delta Fiber switched from ISC DHCP to KEA? I did this project for Delta Fiber to give some context. Then something about the unique features of KEA DCP. Something about the whole migration process, how did we do that? And last but not least, something about monitoring and also an interesting case I will explain to you. The name KEA, they choose the name, KEA is a parrot that lives in New Zealand, known for his problem-solving techniques and adaptability. You see it in the picture. And also, they choose KEA because it's just a short name, so easy to remember. Why migrating to KEA DCP? ISC DHCP, I looked it up. It's already 30 years old. The first code was committed in 1995, so it's pretty old. It's pretty mature, so it's very stable. Delta Fiber uses it for almost 20 years, I guess. But the code base is very old, so ISC did some investigation. They want to refactor the code, but after some investigation, they only thought the header files are useful, so maybe it's better to start all over again. Second thing is ISC DHCP has no modern API, so they had some API with OM API, but that's not so flexible. You can't reach it from outside, so no, it's not very useful. Next thing is that if you want to do changes, for example, adding subnets or adding host reservations, that's all in the config, and you need to do a reboot. So a reload of the daemon. So every change has downtime, and sometimes a reload of the daemon can take up to 5 minutes, and that's not something you want. And last but not least, ISC DHCP has no option to bind your lease to option 82. So the lease was always binded to the MAC address, so modem swaps were not so easy, and that's something that happens a lot if you are a service provider. Yeah, something about the architecture of KEA. The first thing is KEA has a nice database backend, so you have the option to store all your information, your variable information in a database. You can choose Postgres or MySQL. And the things that normally you do in a database are leases, host or subnets. Next thing is that KEA is the code base is very small. So if you want to have extra functionality, like the database backend, then you load plugins. So you can compare it with Apache. Apache has modules. In KEA, they call it hooks or plugins, but they function like a model. So you can extend your functionality by adding extra hooks or plugins. There are a lot of plugins available. Most are free. So as of KEA 3.0, I think all of them are free except the subnets and the access plugin. They are not free, but most of them are free. Then KEA has a very nice REST API. So they have up to 200 different API comments you can use. For example, updating a lease, adding subnets, removing subnets, config checks, reloads, everything you can imagine you can do via the API. On the right side, you see an example of how you add extra subnets. So it's all JSON-based. So if you're familiar with the REST API with JSON data, it's very easy to use. It is also like ISC, high availability is an option. So you can have active-active setup or active-passive setup. And the two servers will check each other if they are live. And what they add is that they also check if their requests are coming in. So it's not only checking each other, but they also have a very smart mechanism to see if the other peer still gets requests and also can answer to the requests. And there's a lot of more. There's very good documentation. So everything you need to know is on the website. It's very extensive, so that helps you to do research and to see how you have to implement things you did in ISC, have to implement in KEA. Last but not least, they have a graphical dashboard called Stork. Stork is a separate project. They started, it's an open source project, and it's meant to run and to monitor all your DHCP instances. For example, if you have a lot of DHCP servers, you can have just a single page, a single view to hold your DHCP cluster, and that can be very helpful. Then something about how Delta Fiber does DHCP. On the left side, you see the client. The client does DHCP requests. They go through the switch or the OLT. OLT does DHCP snooping. DHCP snooping means adding extra information in a request, for example, the unique client ID or the circuit ID where you are connected. And also IP source guard is done on that switch, so it knows what address is given to the client. So you can also do some source guard and do IP spoofing protection. It's very nice. And then at the router, the broadcast segment ends. So the router is the relay. So all the requests, broadcast requests, enter the router, and the router relays requests to the DHCP service on the right side. We have two servers, and at Delta Fiber we use the active setup. So both get a request and both can respond to the request. And they have some algorithm that they decide to what MAC address what server does respond. So they have some mechanism to determine that. At the bottom, you see how the process goes. You have to discover, the offer, the request, and acknowledge. And in the startup phase, the requests from the client are broadcast, so you need that relay to send it to the server. And that's also the reason that it's called the DORA protocol, because discover, offer, request, acknowledge. It's DORA. And also Peter told me there's also an open source project that is called DORA. So there was an open source project to build a new DHCP server, I think in Rust it was, and they called it DORA. So, yeah. Then one of the plugins that Delta Fiber uses the most or has the most benefit from is the Flex ID plugin. Like I told you, the old ISC had only the option to bind your lease to a MAC address. At a service provider, a MAC address can change because users can swap their device. But what you want as a service provider, if you have, for example, fixed IP address, you want to have always the same IP address to that same customer, and you don't want to have that bind to the MAC address, but bind it to another unique identifier. And with KEA Flex ID plugin, you can choose what you want as the identifier for the lease. In our case, we use the remote ID, and the remote ID is provisioned by the provider itself. So we have a unique remote ID, and in the case of Delta, that's the order ID or the service ID of the provider that's provisioned to the network, to the OLT. So with this plugin, we can always give the same IP address to the customer, regardless of what device he is connecting to to his connection at home. At the bottom, you see the old situation. In ISC, you have the MAC address that is filled in the client ID field, but in KEA, you can have some configuration that you can decide what you want to have as client ID. In our case, it's just the SP0, that's the unique code of the customer. Yeah, then another thing we did change by using KEA is that we extended the default lease time. We had a lease time of 30 minutes. Now, the 30 minutes is pretty low. The reason for that was, there were two reasons. One was that if you want to swap CPEs, sometimes the lease does not get deleted. And you had to wait for the lease to expire before you could connect a new device. So we decided to make it low. And there was also some bug in some Cisco router, I think 8 years ago, that they advised us to lower the lease timer. So that was the reason that the lease time was only 30 minutes. But with the introduction of KEA and the issues were solved in the network, we decided, hey, let's go to a longer lease time. So we decided to go to 24-hour lease timers. Now, two reasons for that is that we have more time. For example, if you have a major outage of both your DHCP servers, then you have up to 12 hours to fix your issue. With the old situation, we had only 50 minutes, and that's pretty low. So if you have a major outage, within 50 minutes, clients will drop their lease. Their lease will expire, so clients will go offline. The next side effect is that you have lower load on your platform. So that's also a pretty nice side effect. Yeah, then something about what I told before about the lease affinity. Lease affinity means sticky leases. So at Delta Fiber, we go for sticky leases. That means if you got a lease that's bind to your unique SP0 code, you will always keep that lease. So even if you swap your device, like it's in the picture, you will still keep the same IP address. And that's sometimes very nice. For example, if users have a public IP address they use for their own server, they will always keep that same address up to 30 days. We have a lease. There's a tool running within KEA that if a lease expires after 30 days, the lease will be deleted from the database. So if within 30 days you do a renew or a discover, you will get the same lease. One thing I discovered within KEA is that a lot of CPEs, if you do a reboot of a CPE, then they send a DHCP release message. And in KEA, the DHCP release message is handled as I delete the lease from the database. So in the first test, what I saw is that if I did a reboot, I got a new IPv6 prefix. And that's not something you want. You want to have sticky leases, fixed addresses. So we need to add an extra part of configuration. You see on the screen that all the release messages in v4 and v6 will always get dropped in our case. And that's the way how we fixed it. It was something that KEA also advises to do. Then something about how we built the whole DHCP platform. And on the right side, I have a small diagram of how we build it. In the center, we have the DHCP manager. That's the whole provisioning process. And the DHCP manager is the connection from our OSS systems to the actual DHCP platform. First, you have all the networks, so all the subnets and the routers we have in the fields. And that's in our Nautabot CMDB. So we use Nautabot for all the registration of subnets. The DHCP manager fetch all this information. And on the other side, you see the host reservations. And host reservations are, for example, if a user wants to have a fixed IP address or a public IP address, we have a separate entry and we flag that this user needs to get a fixed or a public IP address. And that information is pulled together. DHCP manager provisions it to a so-called master DHCP server. That's a DHCP server that only does provisioning. So it doesn't do DHCP itself, but we use it for the provisioning. The DHCP manager sends all this information to the API. And the master server also runs a Postgres master database, and we have a lot of slave database that get all the data replicated from the master. The reason we did this is because we have a lot of DHCP servers that needs to have always identical information. We don't trust the provisioning process, but we trust the replication process. So the master receives all the information, and all the information gets replicated by the Postgres replication mechanism, and we trust that replication mechanism. And that works pretty fine. So we can always rely that both slaves have always the same information, because they can have to serve the same request. So you need to have that identical. Only the lease information that's not in a database and the lease information is synced via the API of KEA itself. So the slave service sync that lease information between each other. One drawback of this solution is that if you want to do an update of KEA, some updates need to have a new database scheme, then you need to update as well the master as a slave in one run. Because if you do a reload and you have the new database scheme, KEA checks if the database scheme matches the version. So that's one of the drawbacks. That's also the reason we have multiple masters. So we have a master for internet services, for VoIP and for IP television. We have separate masters, so you can do the upgrade easily. And last but not least, the whole platform is managed by Ansible. We have a wonderful team of engineers that are very good at making Ansible playbooks. So they make a playbook that we can easily roll out new slave servers or update slave servers. Then the migration to KEA. Like I said, Delta has 5 different DHCP clusters on almost 260 routing areas in whole the Netherlands. So 260 different POPs that have routers that have their own DHCP relaying running. And the 5 different clusters are VoIP, IPTV, Internet v4, v6, and we have also some management DHCP server. We decided to start with the easiest platform. In our case, that's VoIP and IPTV. The reason is that we have just single pools, so we have no fixed IP addresses or clients that need to have always a public address. So it's very easy and it's very clean setup. And also we started to do it with pre-production. So we have one router that's actually in production, but that has only customers from the lab or friendly users. So we can easily do migration. And if we have a mistake, we don't have customers that will call us. And also the plan is crawl, walk, run, fly. So just start small. And if everything goes well, build up so that you can speed up the migration. At this moment, we have done the whole migration of VoIP and IP television, and we are currently doing the IPv4 migration. I think we are at 80% of IPv4 routers in all the Netherlands, so we are almost finishing it next month. So if you are a Delta customer, it could be that you have a moment that you will be migrated, but if everything goes well, you won't have any impact on it. And the last step is that we also manage the V6 and the management service. Those services are running KEA, but they are running a very old version, so they need to be upgraded and migrated to the new platform. Yeah, then the most technical part of the presentation. How do you migration without impact from the old to the new server? I try to make it in a diagram. First of all, we have a migration script. We built it ourselves. You can also get it from from ISC itself. They have some scripts, but we created it ourselves because we have our own CMDB. The first thing we do is we add new configuration to the router, so the relay routers know the new DHCP server. And then we import the existing leases from the ISC DHCP server. Those leases will be exported to the new KEA DCP server, so all information of the leases is available in the new server. Then we do a deletion of the configuration of the old DHCP server, and we change the relay settings on the router. And that is the moment that the migration will start. The users that will try to do a renew to the old DHCP server, they will get a DHCP NOG message, means that, hey, I don't have any information anymore, I can't give you that address. The user will try to do a request again, until the T2 timer, that's the rebind timer, starts. And rebinding means that the request is not unicast, but it's broadcast. And it means that the request is not sent directly to the DHCP server, but it's sent to the router. So the router gets a broadcast because you do a rebind, and then the router knows only the new DHCP server, so it will send that message as unicast to the new DHCP server. New DHCP server will answer through the router will answer back to the client, and that's the moment that the user switches from the old to the new DHCP server. So without having to do a whole restart with a DHCP discovery, you can migrate the user while it's just retaining their lease. That's the way how we do the migration. So if everything goes well, basically the user won't have any downtime doing this migration. Yeah, something we also did is we built a lot of monitoring tools before the migration to have clear insight what is going on, if there are some issues. On the first line, you see a monitoring of the pool usage, because we have, the most customers have carrier grade NAT, but we still have users that want to have a public IP address, like the freak nerd users. They don't like carrier grade NAT, and they can request a public IP. But those pools are very small, so we need to monitor the pool usage, and we give alerts if pools are running low. You can see it here. We also monitor for DHCP packet anomalies. For example, if you have a lot of discover messages, then it means sometimes that maybe there's an issue on your platform or a lot of users don't get an address, so there could be something wrong in your configuration. The third one is the migration status for project management. So we had a project manager during the project, and what I did is he always asked me what is the status of the migration, but I think it's easier just make a small dashboard in Grafana with how many routers we have migrated, how many subnets, so we can every day check what is the status of the migration. And the project manager finds it very nice to have just his own dashboard and see what's the status. Then we have also some detailed graph. In KEA, you can monitor every DHCP packet type, so you can see what's going on, how many requests are coming in. So for us, it's if we need to do some analytics about things not going well, we can do a deep dive in those graphs. And last but not least, we also use Elasticsearch for the really deep diving. For example, we can see on a customer level how many requests customer sends. So sometimes we have users that keep hammering, and we can easily track them down and block them directly on the DHCP servers. Like I told, ISC is also a nice monitoring tool called Stork. Stork is a dashboard. If you have a lot of different DHCP servers, you can have a single view. Stork can also do changes to your platform, but we don't use that. We only use it for monitoring and have some insights of how is the platform going. So yeah, it's pretty helpful for our NOC to investigate issues. Then something about the thing that almost killed our network. We had on a Friday this year, there was a user or a colleague that decided to change Nautabot permissions on Friday. So I think that's the first mistake. So on Friday he changed permissions, and the result was that the DHCP provisioning process lost some rights to some tables. So it was allowed to log into Nautabot, but it couldn't fetch all the data sets. So it didn't get an error, it got an empty data set. So empty data set, no subnets. Hey, maybe I need to delete all the subnets. So what happened at 2 a.m. at Saturday night, all the subnets were deleted from the DHCP server, so there was no subnet anymore. What happens is clients that did a reboot or had a power outage, they couldn't get a renew of their lease, so that was the first issue. And about 4 o'clock, 2 hours later, our NOC discovered and got some alerts, hey, there's an issue going on. So they saw, hey, the users don't get a new IP address anymore, there's an issue. Luckily, those people are very smart, they did some investigation, and at 10 o'clock at Saturday morning, the issue was fixed by putting back, restoring a backup. Luckily, we had a good backup, so we could restore a backup of the day before, and everything went well. So the impact was reduced, and the reason also is we had a 12-hour lease time, so we had 12 hours to fix this issue. So luckily, we had, I think, to 10 to 2 in the afternoon, we had the time to fix this issue. Only users that did a reboot are new users. Yeah, those users didn't get an IP address, but luckily, the impact was very limited. But it could have been very worse. For example, if we had a short lease time of 1 hour, then every user will be offline within 1 hour. So luckily, that helped us. Yeah, and last but not least, what we did is that was also something I advised before, and actually it was implemented after this issue. Just do always checks. For example, if you want to delete something from your provisioning system and it's more than one subnet, then you have to give alarms first, or you maybe have some cool-off period, or first inform an engineer, hey, we were gonna delete these subnets, is this right? So luckily that has been implemented. Oh. Okay, my last slide, conclusions. If you're currently running ISC DHCP and you want to migrate, I think everything what you currently do in ISC is possible in KEA, and much more. Especially the plugins that are available in KEA can make your life pretty easy. There are a lot of things you can do via the API, so I think it's very, very helpful. And you have all different ways to provision or to query the system. Next thing is that whole separate database backend. So having a separate database backend makes it very nice to manage your whole platform. So you have a very small config with only the essential things. Everything that's variable is in a database. So it makes it very good manageable. And also if you have a large user base, then you can just have everything in the database backend and don't need to do config changes a lot. About the stability, I think Delta Fiber is running KEA for almost 4 years now, and we didn't have any issues. So it's very stable. So we didn't have any crashes, only small things, but they were fixed in versions that came after. So KEA helped us a lot with fixing issues. The next thing about the migration, the way we migrate with including the leases in the migration. So not only new config, but also migrate your current leases to the new system. I think it makes it very customer friendly. So I always advise you to take that in account. The only thing is the Stork tool we use. that was the only system we had a lot of bugs. So if you install Stork, currently it's a bit more stable, but the first versions had a lot of issues with statistics that were not right, things that were crashing. So we also migrated to a separate server, and now it's pretty stable. And last but not least, implementing DCP is not only implementing the software, but I think it's the whole ecosystem. So deploying a whole new DCP platform, I think it's important to look at those things and make also good design decisions. So making good design decisions can make or break your DCP platform. So if you're still running ISC DHCP, I strongly advise you to migrate, and I think the time is right. So that was my presentation. So
thank you, Rinse,
for questions.
So now I have a question, and the question is, are there any questions? For the benefit of the remote viewers, please state your name.
Hello, this is Andrei Tsaletka from Ripen CC. Just a small update. KEA version 3 actually dropped the proprietary plugins and replaced them with open source because they figured out that selling plugins doesn't make any sense. So it's now completely open source, and you don't have to pay support contract with ISC to get these hooks. Yeah,
it's a very good remark. All plugins are free. The only are the subnets and the RBAC plugins. So if you want to have some subnet backend, or you will want to have role-based access, I think it's for very big ISPs. But if you are a small ISP, you can do it open source version. Yeah, agree. I think that's a very nice move from KEA. Thank you.
Thank you, Andre. Are there any other questions? Yes.
Hello, Jakov from Nebius. Thank you for the presentation. I just wonder if you are doing prefix delegation and providing your customers with /56 of IPv6 or something like that. And is there any difference between ISC DHCP and KEA in that regard?
Yes, we are doing prefix delegation. So Delta Fiber, we hand out /56 to users. And I haven't done that with ISC. Within KEA, it's very easy. I know in ISC it was possible. In KEA, it's also possible, and I think it's easier than if you do it in ISC. So, it's pretty easy to do. And also the reason we want to have least affinity, that's the reason, because if you have V6 prefix delegation and you change the prefix to the customer, that will have a lot of impact. So that's also the reason we want to have that always fixed.
Awesome, thank you.
Yeah, thank you.
All right, thank you again, Rinse. We have a small present to remember this presentation.